Hey everybody, Milks here flying solo. Reworked video 5 real quick. We're going to figure out saturated, unsaturated, supersaturated, and then how to look up the amount of stuff that will dissolve on table G and play some math games. So got to go quick. There is a lot going on in this video and a lot of examples. So if I am on the line, I'm saturated. So here's an example, 40 grams NaCl, 90 degrees. So 90 degrees, 40 grams, boom, look at that right there. My smartboard's off a little bit, but my plot comes right up onto the line of interest. On the line is saturated. Below the line is unsaturated. So 70 grams at 60 degrees, 60 degrees, 70 grams, that's here. I trust that you can plot these things pretty quick. Now I deal with KNO3, look, I'm below the line. So below the line is unsaturated. And then again, above the line is saturated. You plot this one, you'll see that I'm above the line. I need to save some time. Here we go. Rules. What I need to do is, for finding how much will dissolve or won't dissolve or change in temperature will precipitate, I just need to look these things up on table G, first of all. So use table G, find out the amount that will dissolve at that temperature. If it's 2, subtract if it changes. It's going to happen every time. So here's another example. Mass dissolved versus mass at the high temp versus low temp. You got 2 temperatures, find out the 2 different grams, subtract the final from the initial values, and boom, we're off to the races. I'm going fast because I got to go fast. If I can get 30 grams of something to dissolve into water and I double the amount of water, shouldn't I be able to double the amount of stuff? Yes, that's the rule. So here it is. If I double the amount of water, then I can double the stuff. And here's the trick. The biggest trick here is this whole chart is based on 100 grams. So if I have 200 grams of water, I've obviously doubled the amount of water, so I can double the amount of stuff. If I have half the amount of water, can do half the amount of stuff. That's really it. And then this last piece is solids versus gases. And real quick, solids will be able to dissolve more stuff as I heat up. So they will go up. Gases going down. I will dissolve less stuff if I'm a gas. So just using those rules about how I get more and less stuff to dissolve, heating up, cooling down, gases, solids, we can use the slopes of the lines to figure out if I am solid or a gas. Now let's get into playing some games. There's 3 of these examples. I'm doing one for time. Watch. 60 grams of HCl and 100 grams at 47 degrees. Am I saturated or am I unsaturated? Or supersaturated? Remember, we got to use the definitions from before, earlier. 47 degrees is right here. 60 grams, oh, look, right there, and I'm dealing with HCl, so I'm right on the line. Therefore, I am saturated. Now notice, if I would have ended up below the line, I would have been unsaturated. If I would have ended up above the line, I'd be supersaturated. So you can now plot and graph this one. It's next. Do it. Then do this one next. I'm not doing them. I just did one. It's that simple. Do it. You'll get it. Okay? Next kind of example. NaNO3 at 40 degrees. How much do I have to add to make a saturated solution, Mr. Milks? Well, at 40 degrees, find my NaNO3. NaNO3 is this line right here, and so it crosses right there at about 105. So I need 105 grams to make a saturated solution. I can do this because I know saturated solution means right on the line. So very easily, you can do this one, KLO3 at 30 degrees. Figure out where that is. And then that's how many grams to be saturated. Again, KNO3 at 50 degrees. Find 50 degrees, go up to KNO3. That many grams on the line would make a saturated solution. I know I'm stressed. I want to try and get this in the 10 minutes. All right. Next kind of game we can play. 60 grams KNO3 are added. How many grams did not dissolve? All right, well, let's look at 20 degrees, okay, and 60 grams, bam, right there. And then we look at KNO3, which is all the way down here. So I should only be able to dissolve, 35 grams, and I put in 60. So 60 minus 35 gives me 25 grams that does not dissolve. So you see what I did? I subtracted the 2 values, the line and the plot. Okay, that's how we do it. So you're gonna have to do that again for this. This one, there's gonna be 2 different dots. You gotta look them both up and subtract them. Can you do that? You can do that. All right. Next kind. Find the mass of a solute that will precipitate as I cool. So now I'm just dealing with two temperatures, same chemical. I'll show you one. You do the next one. Ready? NH4 at 75 degrees. That's about here. And 15 degrees. That's about here. And I'm dealing with who? NH4Cl. NH4Cl is this guy. So at 75 degrees, I can get about 65 grams to go in. And at 15 degrees on the same line, this is the trick, you got to get to the same line, I can get about 35 grams to go in, and I'm writing a little sloppy. So how much precipitates out? 30 grams. Boom. I might have skipped over a very similar problem, but I'm only doing one. Notice it's just two different dots. I'm subtracting the difference between that plot and that plot. And the difference is actually right here. Right? Okay, good. In the Y value, if you will. This is another one of the exact same kind, so I'm not going to do it. How much will precipitate? Find the amount at two temperatures. Okay. The mass of solute that could still be added. In other words, I didn't add enough. So again, I'm going to have two different spots, and I'm going to subtract. So I'm going to go 55 to 65, so 55 and 65. I'm going to deal with NH4Cl, which is this guy. And so I got here, and I got here. So I put in 55 grams, and then all of a sudden, check it, it'll hold 60. So when I heat it up, so how much more could I add? I could add 5 more grams. Finding the two spots, or the two dots, subtracting them, and we are on our way. You guys getting the hang of this yet? I'm going to keep moving because there's other different kinds of games. Another one you can do. Okay, find up your two temperatures, subtract your two numbers of grams, and you're on your way. Next kind. If other than 100 grams of water, now this is where things get fun. Okay, 40 degrees KNO3. 40 degrees KNO3 is this guy right here. And at 100 grams of water, I can get 65 grams to go into solution, correct? But it says I only have 50 grams of water, which is half. If I have half the water, I can get half the stuff to go in. So divide this number by 2. Now we're talking 32.5 grams will go into solution. Because I have half the water, I can get half the stuff to go in. Does that make sense? I hope that makes sense. What if I double the amount of water, Mr. Noakes? Well, then guess what? We can double the amount of stuff. Let me go through this because this one's key. 50 degrees, bam. KNO3, got it. Here we go. It's right here. I can get 85 grams to go into 100 grams of water. Well, if I got 2,000 grams of water, oh my God, I multiplied it by 20. 100 times 2, times 10, 20. All right, so I just multiplied this number by 20, and I'm going to get a number. So 85 times 20, okay, on milks, 85 times 20, 1,700 grams, 1,700 grams I can get to go to solution. Ooh, all right. So that's the game we can play. So now 25 grams of water, that is quartered. So look up your number, divide by 4. Got it? Quarter, 25 is I did it. We got all the way through it with a minute to spare. Wow. All right, let me go through and do this one then since I got some time. 25 grams H2O at 30 degrees. So get that part right. I'm going to go up to KNO3, where KNO3 is. I find KNO3. I can get about 48 grams to go into solution, but 25 grams is a fourth of 100 grams, right? So I'm going to divide this by 4, and I'm going to get 12 grams is all I can get into solution. If I can get 48 grams to dissolve into 100 grams of water, I can get a quarter of that to dissolve in a quarter of the amount of water. Make sense? Those are all the games I can play with Table G. I hope you understand how to plot. Looking at your temperature first, go up to the line of interest, or what should be at the line of interest. Saturated is on the line, unsaturated is below the line, supersaturated is above the line, and we out. I pressed the button and I turned off the video.